for today. So like I said, what we're going to chat about today is fractions. So my first question here is, what does a fraction tell us? So why do we use fractions? What do they represent? How can we use them? That's sort of what I'm asking here. So have a think. If anyone wants to raise their hand and try to give me an answer, please do. Otherwise, you can pop it in the chat. I'm going to give you a few seconds to think about an answer to that question in terms of why are fractions helpful to us? Why do we use them? What do they tell us? No one. Okay, no problem. All right, so fractions, guys, fractions actually do a lot of things for us, but in a basic sort of statement, a fraction represents a part or portion of a whole. I can't spell represents apparently. Represents parts, or you can say portions of a whole. And as Andre put on the chat there, the percentage being shared, which is pretty much a very similar thing. So it's the parts or the separate parts of a whole that either make up the whole or that we're considering within the whole number, how many parts we're working with. So I'm seeing some of those sorts of ideas coming through on the chat, which is very nice, well done. But that's essentially what a fraction does. Now, fractions can come in many different forms, which we're going to chat about today, but excuse me, fractions represent part of a whole. You would have seen fractions before. We can represent fractions as ratios. So if you've worked with ratios before, that's basically like a fraction. But the important bit here is it's representing part of a whole. So if we think about like a visual representation of this, so apparently that's a square. If we think about a square, I was trying to draw a square, but apparently everyone wanted to fight with me. And we separated the square into, let's say, thirds. We could use a fraction to show that we're talking about one part of this whole. If we separated the square into 9 blocks, we could use a fraction to represent that we're talking about, let's say, 5 of those 9 blocks. So this is what I mean when I say we can represent parts of a whole with a fraction. Right, excuse me. There's many different applications to fractions. So Bridget's put a really nice one there on the chat in terms of sometimes we can use fractions or even ratios in baking and cooking. If you think about if you're mixing like Oros or Energade, you have to mix it in a specific ratio. I know we don't always do that, but you're supposed to. And so those are sort of like applications of our fractions. If you think about you order a pizza with your friends and you want to share the pizza out, you're taking the whole thing and you are giving parts of it or representing or sharing parts of it. Alrighty, so that's essentially what a fraction is. Now, Tsapang has also put quite a nice definition of a specific type of fraction that we're going to look at, but I'm going to get there in a second. Right, so like I said, we've got different numbers that can involve that can involve fractions. Now here, I've only got mixed numbers and improper fractions, but Tsapang has actually reminded me that we have a very basic type of fraction, which is our common fraction. The spelling, the everything tonight is just not going well for me. Right, so let's have a look at what a common fraction is, and I'm going to start there. So Tsapang has put that on the chat already for us, which is very nice, thank you. A common fraction is basically, I don't want to say our most basic form of a fraction, but what we automatically think of when we have a fraction. Now, guys, importantly, there's 2 parts to a fraction. We've got the top and we've got the bottom. Those have specific names. It's not called the top and it's not called the bottom. Our top is our numerator. And our bottom number is our, oh, golly, Miss Molly, is our denominator. Okay. And so a common fraction is when our numerator is smaller than our denominator. Can't spell. Numerator is smaller than the denominator. And so there's so many, there are so many examples of this that we can use. Your denominator, I promise you I can spell. Clearly today is just not my day. So we can think of a half, we can think of 3/4, we can think of 11/15, we can think of 121/700. As long as your numerator or the top is bigger than your denominator, we're working with what we call a common fraction. And so what it's doing is it's representing not a whole, but parts of the whole. Okay, so I'm going to come back to this. So if you don't take a screenshot now, don't stress. What I'm going to do is once we've done all of our definitions, I'll put all of the definitions on the screen so you can take a screenshot. The other type of fractions that we can work with are mixed numbers and improper fractions. So does anyone want to give me a definition for either of them? You can do mixed numbers or improper fractions. And when I say a definition, you can give me an example if you want, but just what is a mixed number? Sorry. And what is a improper fraction? Oh, no, Babas. You can just, if my cat's face comes into the camera, just say hi and we can move on. Sandawami, which one do you want to give me?
I think a mixed number is when there is a whole number and a numerator and denominator.
Well done, excellent. So we can say a whole number. We could also just say an integer, because sometimes they can be negative, with a fraction to it. So lots of you are giving some really nice examples in the chat there. And really, once again, it could be anything: 3 2/3, 1 1/5, 7 1/2, etc., etc., etc. So a mixed number has a integer part or a whole number part to it, as well as a fraction. Now we're going to chat a little bit more about mixed numbers in a second, but let's quickly figure out, or let's quickly define for ourselves what an improper fraction is before we take a closer look at these. Nadia, do you want to try improper fraction?
Yes, ma'am.
Okay.
Ma'am, I think an improper fraction is a fraction where the numerator is greater than or equal to the denominator.
Okay, excellent. So for an improper fraction, our numerator is larger than our denominator. Now, Nadia put in there, let me maybe just finish my words because clearly I'm having a problem tonight. Nadia also stated that it could be equal to. Now, remember, if your denominator and your numerator are equal to each other, you actually end up with 1. And so for the most part, an improper fraction represents a whole or multiple wholes and then some more. So for example, 7/2 or 9/4. As long as your numerator is larger than your denominator, we've got an improper fraction here. And again, any sort of example that you want, as long as the top is bigger than the bottom. Right, so there are all three of those definitions rather, for you to take a screenshot. I know there were other hands, but I promise you we've got more questions coming up, so there will be chances for you to try, so don't worry. But take a screenshot of this and then we'll have a look at some examples. And very nicely done to all of those people who were giving us improper fraction definitions on the chat. Saw them all coming through, very nice. Okay, I'm hoping we've all got our screenshots. I'm moving on. So let's have a look at sort of different ways we can work with fractions here. So the first thing we need to understand about fractions is that because it's representing part of a whole or parts of a whole, we can always write equivalent fractions. Now, basically, if we break down this word, equivalent comes from equal. And so basically, these are fractions that look different but represent the same proportion. We'll get there. So you can look at those pizzas down at the bottom and try think for me how you could write those as fractions. Proportion. Right, so if we have a look at those pizza diagrams, here we've got 2 parts in the first one. So think about how many parts you have. Moniswa, do you want to try the first fraction? How could I write it as a fraction? There should be a pop-up that lets you unmute. There we go.
Ma'am, it should be 1/2.
Perfect. The shaded region is 1 part of the total 2. Excellent. Well done. Oh, we've got so many hands. Okay, Sapang, do you want to give us the second one? Excuse me. Sapang, you there? Okay, I'm going to move on. Amahle, do you want to give us the second one?
It's 2/4.
Perfect. 2/4. We're going to discuss these all now, guys, so don't stress. Kagiso, the third one?
It's 4/8.
Perfect. Excellent. Well done. Lufuno, the fourth one?
Ma'am, it's going to be 8/16.
Excellent. Well done. Right, so guys, we've got all of these fractions here, but if we actually go and have a look at what portion of the whole they're representing, we can see that in each case, it's half the pizza or half the pie. Now, like we said, all of these fractions look different. We've got a half, 2/4, 4/8, 8/16, but they actually all represent the same portion of the whole. And so these are what we call equivalent fractions. They actually are all equal to each other. Now we know this because if we simplified each of these fractions, so each of the last 3, we would get a half, and a half. And so just because the numbers aren't 1/2 doesn't mean that fractions can't be equivalent or be equal to each other. So equivalent fractions, like I say, different numbers or fractions that look different but actually represent the same proportion. Right, I see 2 hands, Dalo and Zoe. Babes, come. Okay, no, we're all sorted. Remember, guys, if you do have a question at any point, you just need to raise your hand or put it in the chat and we'll help you. Right, so let's have a look at our first example when talking about equivalent fractions. Just in case you didn't, just in case you didn't get your screenshot, there it is again. And let's have a look. Right, so in each of these cases, I'm asking us to fill in the missing values. Now, what I want you to take note of here is the fact that there is an equal sign between each of these fractions. So these are those equivalent fractions that we were talking about. We want each of these fractions to represent the same proportion. So have a think. Actually, let's try the first one together and then I'll ask for some hands. So if we think about, excuse me, the first fraction, we've got 4/5. Now you can draw it out if you want to, but that becomes a little bit time consuming in a test. So the question we need to ask ourselves is, what am I multiplying 5 by to get 15? Well, if I multiply that by 3, 5 times 3 is 15. Now, the reason we ask ourselves that is because we can then apply exactly the same method to my numerator. And as long as I'm multiplying my top and my bottom by the same amount, I'm keeping that fraction within the same ratio. I'm keeping it equivalent. And so an equivalent fraction to 4/5 could be 12/15. Now, if we want to get the second one, you can look at it however you want. I'm just going to refer back to the first fraction. If we look at our second one, what are we timesing 4 by to get 24? Well, if we times that by 6, I'm going to get 24. So that means I must times 5 by 6 as well in order to get my denominator. So we've got 24 over 30. Okay. Now, you don't have to do it from the first fraction to the last fraction. You could have said, okay, well, 12 times 2 is 24. And so 15 times 2 gives me 30. Because they're all equivalent fractions, you can work with any one. They represent exactly the same thing. So you have to decide what you think is a little bit easier for yourself in order to get those equivalent fractions. Right, so take your screenshot, and then I'm going to ask you to try B. Doing really nicely. Okay, let's have a look at B. So I want you to try B for me. What I'll actually do is I will leave that up just so that you can see what's happening, just in case you need some help. So guys, remember, what we're wanting to do here is we're wanting to get equivalent fractions. So as we go from one fraction to the next, we're asking ourselves, okay, if we go back to the first one, if we compare the first fraction and the second fraction, both of them have a denominator. So what did I times the 5 by to get 15? Well, I times it by 3. So if I do the same thing in my numerator, I will get an equivalent fraction. So that's what we're trying to do here in our first example. Remember, you can always use the chat for your answers if you want, and you're welcome to raise your hand. See, someone Nisa already has their hand up, but I'm just giving everyone a chance to try. Okay, let's see. Timothy, do you want to try this question B for us?
Times 12 much.
Okay, perfect. So guys, the question I want to ask myself is, to get from 7 to 84, what am I timesing 7 by? Exactly, I times it by 12, which means I must do the same thing in my denominator in order to get the equivalent fraction. And we know that 8 times 12 is 96. So 7 over 8 represents exactly the same proportion, or exactly the same parts of the whole as 84 over 96. Okay, now we still want to get this last fraction over here. Does anyone want to give that a try? Guys, please remember to mute yourselves after you've answered or asked a question. Otherwise, it does become a little bit chaotic. Amatle, do you want to try the second one? Or the second fraction here?
You say 8 times 5, and then you get 40.
Perfect. So if we say 8 times 5, we get 40. So Amatle, what do we need to do to the top?
You have to times it by 5.
Excellent. So we also need to times 7 by 5. And we know that 7 times 5 is 35. And so what we've done is we've taken the fraction that we know, and we've seen what is the same thing I can multiply the top and the bottom in order to create an equivalent fraction. Okay, so guys, if we look at these fractions over here, we've got 7/8, 84/96, 35/40. If we drew a picture, they would all be the same amount, or the same proportion would be shaded in for each of them. If you simplify 84/96, you're going to get 7/8. If you simplify 35/40, you're going to get 7/8. And so they all represent exactly the same proportion of the whole, exactly the same fraction of the whole. So we need to be looking at the fraction we know in order to see what we're timesing either the numerator or denominator by to get the next fraction. So I'll let you screenshot if you want, and then we're going to have a look. We're going to have a look at one more, and then we'll take a break. Pretty sure I have one more. Right, last few seconds to get your screenshot. Right. So this one, we've got 5 fractions here. So I clearly didn't feel like putting a number here. This is C. We've got 5 fractions here, and remember, we want the equivalent. So what you want to do is you want to look at the fraction you've got at the start, and you want to ask yourself, what am I timesing 7 by to get 14? If you guys aren't doing fractions at school yet, don't worry, you're eventually going to get there. Hopefully this will then help you feel more confident when you do start doing them. Right, so try get those 5 equivalent fractions for me. I suppose it's actually 4 equivalent fractions. The 5th one's given to you. I like what I'm seeing in the chat so far. Very nice, guys. In grade 9s, I'm going to remind you again that if you want to know what courses are coming up, you can, or you need to look at the front page or the starting page of this video when it's uploaded, because I do list there all the courses that we have coming up for the term. All right, just that you can find it and you can see. Moniswa, do you want to try the first one for us? Moniswa, you want to try?
Ma'am, I think for number C, you times 6 by 2, and then
Perfect.
And then times 80 times 6 by 3.
Okay.
And then times 6 again by 5.
Okay.
Times 6 by 5. Then times 7 by 7.
Good. Very nice. Well done. Okay, guys. So we've got all of those answers here. We see that in each case, we're multiplying by the same thing at the top and the bottom in order to get our equivalent fraction. Got a thick pen at the end there. And so our equivalent fractions here are 12/14, 18/21, 30/35, and 42 over 49. They all represent exactly the same proportion of a whole. If we drew a picture, we would be shading in exactly the same amount for each of those fractions, like we did over here with our pizzas. Yes, there's different parts or there's different amounts of slices, but when we shaded in, it was still a half all the way across. And so for all of these equivalent fractions that we've just practiced, the same thing applies. If you drew a picture, you would be shading in exactly the same portion of the whole. Right, so I've just done that in case you didn't get screenshots earlier. You can take a screenshot of C. And guys, equivalent fractions is a very important concept that we need to be mindful of, just in terms of being able to manipulate a fraction to still represent the same thing as what it originally did. So I'm just waiting for everyone to take a screenshot. And then we're going to take a little break for everyone who's new. About halfway through the lesson, we take a little break because obviously it's quite long to sit for an hour and try and do math for an hour. So we take a little break. If you need to run to the loo, that's your chance to do that. But I also do put up like a little math puzzle or math challenge for you to try, and then we carry on with our lesson. Right, I'm assuming we all have screenshots. Let's have a look. Whoopsie. Let's have a look at our brain break for today. You always get a joke with a brain break, whether you want it or not. So our brain break here, guys, is what I've given you is essentially a set of clues on the left-hand side for you to go and find the value of each of these shapes in order to work out the value of these equations here. Now, very importantly, the value of the shape is not necessarily how many sides the shape has. So a square doesn't necessarily represent 4. Or did we do this last week? Was Andre? Am I just losing my mind? Let me check.
Oh, yes, we did.
Did we?
Was it the same thing?
No, we didn't. Did we do it on Tuesday? Oh, we did it on Tuesday. That's why, because I've just lost my marbles. Everything's fine. Don't stress. I've got another one for you. You can ignore me. There we go. See, prepared. Okay, so ignore me. Try this brain break. We want the value. It's very similar. We want the value of the plant, the leaves, and the sunflowers. What I just want you to take note of is over here, you've got 2 small leaves and 2 big leaves. So have a think, have a try. We'll get some answers in a second. I hope you're all enjoying the joke. They're very cheesy jokes, as some of you will well know. Remember to take a very careful look at the operations that you're using in these equations. We don't want to do the wrong order of operations. So remember your BODMAS or your BEDMAS, your order of work. Seeing some nice answers coming through for the first one. Very nicely done, guys. And again, take note of whether or not there's 1 plant or 2 plants, where there's 2 leaves or 4 leaves, etc., etc. Okay, if we're struggling a bit, Eddie, do you want to help us out with the first one?
Yes, ma'am.
Okay.
So it's going to be 5 for them.
Perfect. So 5 plus 5 plus 5 gives us 15. So guys, 1 pot plant is equal to 5. And I'm making very clear it's 1 Tandawami, do you want to help us with the second one? Tandawami, you there?
I think it is 25 plus 25. I think it's 50. Or I think it's 5 plus 5 times 5 times 5 5 plus 5 times 50.
Okay, really close, but remember we have to do the multiplication first. That's according to our BODMAS. Now guys, remember BODMAS, whoops, panic. Remember, one plant was worth 5. Over here I've got 2 plants. So that means each of these is actually worth 10. It's worth double what one pot plant is. So if two pot plants is worth 10, we are saying 10 times what plus another 10 should give me 150. So Wanga, do you want to help me out here?
Yes. So
Yeah.
I think the leaves are 15. Can I say 15?
Really close. So remember, we've got it plus 10. So if we minus 10 on this side, what am I left with? I'm left with 140. So 10 times what gives me 140?
Oh.
Does that make sense?
Yes, it does.
Okay, cool. So do you agree it should be 14?
Yes.
Excellent. Well done. Okay, so guys, our double leaves there, remember I said it's 2 small leaves and 2 big leaves. That's equal to 14. So now I know my double pot plants are 10. My double leaves are 14. Siyabonga, do you want to help us with the next one? The sunflowers? Sorry. Siyabonga, are you there? Okay. So Moniswa, do you want to help us with the next one? Simboniswa, you want to help us?
Ma'am, I think it's Ma'am, I think it's 3 times 3 plus 2.
So remember, we already know what the double leaves are worth. So if the double leaves are 14, the single leaves must be 7.
7.
Okay. So do you want to try again? You don't have to. I can ask someone else.
Yes, please, ma'am.
Okay. Right. So guys, you needed to take note of those leaves there. Chris, do you want to help me out? Chris, do you have an answer for this one? Okay. Dalo, do you want to help me? Oh no. Dimpo, do you want to help me here?
It's gonna be 6 times 6 plus 7, which is gonna be 43.
Perfect. So 6 times 6 is 36 plus 7 exactly gives me 43. So now I know the sunflower is 6. Alrighty, well done. So Zoe, do you want to give me the last answer here? And remember, guys, order of operations.
The answer is gonna be 6 plus 5 times 7.
So remember, it's a double pot plant, so it's 10. And remember, we need
Oh,
to
yeah.
do the times first.
So it's gonna be 6 times 7, which is 70.
No, remember, it's 10 times 7.
Oh yes, 10 times 7, which is
Yeah.
70
Good.
plus 6,
Which is?
which is 76.
Excellent. Well done. So guys, 76 there was our final answer. And really, really important, you have to do the multiplication first. That is your order of work or BODMAS or BEDMAS. You need to follow that. So if you don't do it in the correct order, you'll get a funny answer. Right, very nice, guys. Well done. Let's carry on with some more fraction examples, some more fraction discussions. And this time, or in this example, I just want to chat about simplifying fractions. And we sort of spoke about that a little bit with fractions. But what we need to remember is that whenever we work with fractions, we always want our fraction to be in its simplest form. I'm just going to make a note here because that's very important. Now, when we simplify fractions, basically what we want to do is we want to ask ourselves, is there any number that I can divide into both my numerator and my denominator without a remainder? So I'm going to do the first one with you, and then you guys will try the rest. So if I look at my first fraction here, I've got 12 and I've got 15. So I want to ask myself, what number can I divide into both of those without a remainder? So basically, what is the highest common factor between 12 and 15? And so we know that the biggest number I can divide into both of these, actually, let me write this on the other side, is 3. And so if I divide both of those values, or both my numerator and denominator by 3, 12 divided by 3 is 4, and 15 divided by 3 is 5. I always just double check myself to make sure that I can't simplify that more. I know that I can't because there's no other number that can divide into both 4 and 5 without a remainder. And so I have simplified my fraction. Now, guys, what's quite nice, actually, no, I'm going to tell you this later. Right. Who wants to try, or rather, here is B and C. What I'm going to do is I'm going to make it a little bit smaller just in case you want to have a look at what we did. I want you guys to try B and C for me. Think about what you could divide into both the top and the bottom without a remainder. If you're going to put answers on the chat, please just remember to number them. So say B's answer, so B and then answer, and then C and then answer, just so that we know which is which. And all of your answers should be a fraction. Because remember, I want you to simplify the fraction. Nice, guys. Doing very nicely. Right, Atini, do you want to help me with B?
Afternoon, ma'am.
Hi.
Ma'am, for B or C, ma'am?
Sorry?
Is it B or C?
You can do either one. Which one would you like to do?
C, ma'am.
Okay, we're going to do C. We'll come back to B. Someone else can answer B. Atini, do C for me.
Yeah. For B, I multiplied by 5 to get the answers I got. So I said 20.
Mhm.
Yeah. I divided 20 by 5, which equals 4, and then 65 by 5, which equals 13.
Perfect. So for C, we know that the biggest number that can divide into both 20 and 65 is 5. And so exactly as Atini's told us, divide them both and you get an answer of 4 over 13. Very, very nicely done. Lufuno, do you want to give me B?
Yes, ma'am.
Okay.
For B, ma'am, I divide 3, ma'am.
You divided by?
3, ma'am.
Okay, so let's divide these by 3. What do you get?
I got 9 over 20. And then I simplified it more and I got 3 over 7.
Okay, so what is 63 divided by 3?
It's 21, ma'am.
21, perfect. And so now, as Ufuno said, guys, if we divide each of these by 3 again, we can simplify even further. So 9 divided by 3 is 3, and 21 divided by 3 is 7. And now I can't simplify anymore, and so I'm done. And this was a really nice example of showing you that once you've divided, always double check that you can't simplify further, because 9 over 21 is not the simplest form. And so we divide again so that we can get it to our simplest form. Now, what I was going to say earlier is what's really nice is your calculator automatically does this for you. So here, I don't know where my camera is. If we type in 27 over 60 and we push equals, our calculator why did I say over 60? Let's maybe do the actual thing. 27 over 63 and we push equals, our calculator automatically gives us this 3 over 7. And so your calculator will automatically or will always give you the simplest form of a fraction. And so if you want to double check yourself, all you do is type it into your calculator and make sure that your calculator's answer and your answer match. Okay, because like I say, your calculator will always give you the simplest form of the fraction. So take your screenshots